major objective of this webinar is to help you who are in your high school and going to be in your +1. So I would like to help students who are in their high school to smoothly adapt to higher secondary school level chemistry. I used to get feedback from students when they enter into their +1 about the difficulties that they face in understanding, especially these topics: atomic structure, thermodynamics, chemical equilibrium, electrochemistry, structure of compounds, especially organic compounds. Out of these 5 topics, we will be discussing the first topic, which is atomic structure. I can assure you that at the end of this webinar, you will be equipped to learn atomic structure when you enter into your +1 course. In the first week itself, in your +1, you will be starting to learn atomic structure. At the same time, you will be started to learn about the physics, especially the physical worlds and the motion in straight line in physics. If you compare these 2 chapters, that is atomic structure in chemistry and motion in physics, you may feel physics is easy to learn and understand. Why this happens with most of students? I actually wanted to know, so I had discussion with the students. So they said, for example, the topic motion in physics is well known to you. For example, if I say I am throwing a stone to the sky, you can visualize it very easily because you have thrown stone yourself in your childhood, right? Or if I say a car is moving at a speed of 50 km/h, you can easily visualize it because you have seen the movement of cars. So it is easy for you to imagine about motion of these objects. So that's why you are feeling that the first chapter of or the second chapter of physics is relatively easy to learn compared to the first 1 or 2 chapters in chemistry. But in the case of atomic structure, this is different because none of us have seen an atom. Whether anybody has seen an atom? Have you seen an atom? Whether anybody have seen an atom? No, right? We haven't seen any atoms. We haven't seen any electrons. We haven't seen a nucleus. Now, if I ask you to imagine an electron which is moving in an atom, can you visualize it? You have not seen that thing, right? Most of the time, it will be very difficult to visualize because it's very difficult to imagine a thing that you have not seen before. That's the problem. Second point is the size of the atoms and the particles in the atoms. They are extremely tiny, which is very difficult for us to imagine. I have shown a size comparison of atoms with other particles such as like a hydrogen atom. See the size, it's in the range of 10 to the power minus 10 meter, very, very tiny, right? Hemoglobin, 10 to the power minus 8 meter. Grains of sands, we know that grains of sands are very, very tiny, still the size is 10 to the power minus 4 meter. What it indicates? For example, a hydrogen atom has only 1 by 1 lakh of the size of a grain of a sand, which means if you break a tiny sand particle into 1 lakh pieces, that one piece will be having the size of a hydrogen atom. These tiny sizes of atoms also will make difficult for us to imagine or visualize about atoms and subatomic particles. Now you know why students feel that physics is easy to learn compared to chemistry in the initial days of your +1 classes. Mainly 2 reasons: because we haven't seen the atoms, the subatomic particles, the nucleus, etc. Second, the sizes of the atoms. They are very, very small. It's difficult for us to visualize. Now, now if I ask you a question, why we should learn atomic structure? All of you studied basics of atomic structure in your 8th, 9th, and 10th standard. At any point of time, did you ask yourself why I should learn about atomic structure? Without knowing atomic structure, can I perform chemical reaction? Yes, without knowing atomic structure, I can carry out chemical reaction. For example, if I want to do a neutralization reaction, you have studied about neutralization reaction. Example, hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. To carry out this reaction, whether we have to know the structure of hydrogen atom, chlorine atom, sodium atom, oxygen atom, is it necessary? Can you perform an experiment without knowing the atomic structure? You can, right? You can answer this question. You can carry out n number of experiments, n number of chemical reactions without knowing anything about atomic structure. Am I right?
Yes, sir.
Yes. Then why we should learn atomic structure? We don't have to learn atomic structure to carry out the chemical reaction. Mainly in chemistry, we are studying about chemical reaction. We don't have to know about atomic structure to carry out a chemical reaction. It's not necessary, but it's very, very important to learn atomic structure. Why? We will study. If you recall the definition of chemistry, you are studying chemistry as a separate subject for the last 3 years, right? If you recall the definition of chemistry, it is a study of structure and properties of matter. In the definition of chemistry itself, there is a mentioning about structure. So structure of atoms, molecules, and compounds, they have a significant role in chemistry. For example, if you want to explain the behavior of an element, for example, oxygen is a highly reactive gas, right? It's a highly reactive gas. At the same time, nitrogen is not much reactive. Argon is not reactive at all. Now, how can we explain these behaviors? All are gases. All are gases. All are made up of atoms. Why oxygen becomes highly reactive? Nitrogen, not much reactive. Argon and neon, they are not reactive at all. How can we explain the behavior? There the question comes. How can we explain the behavior of atoms? So to explain the properties of atoms and molecules, it is necessary to have knowledge about atomic structure. But in your school itself, you have studied different models to explain the atomic structure. All of you studied about the atom model of John Dalton, who coined the term atom in 1803. In 1904, J.J. Thomson, plum pudding atom model. After that, Rutherford, nuclear model of atom. Later, Niels Bohr atom model. Then modern concept of atoms, we started with the Erwin Schrödinger. So many atom models. Why we require these many atom models? Most of the given models you are already studied. Most of them, these models, except the last model, everything you have studied in your school. If we will be looking in detail on each atom model and list their advantages and limitations that we will study later. So one more question now. Why we have to learn about atomic structure and learn all these atom models? It's mainly to explain the properties of atoms. Very, very important. Why we need atomic structure? Why we have to learn atomic structure? To explain the properties of atoms. Why oxygen is highly reactive? Why fluorine is highly reacting? Why sodium is a highly reacting metal? Why chlorine is a non-metal? Why some atoms or why some elements are radioactive in nature? Why some atoms are having color? Why some atoms are solid? Why some atoms are metals? Why some atoms are non-metals? All these properties can be explained with the help of one of the atomic model or atomic structure model. Till now, if you have any questions, you can ask me. It's a basic thing. We are going to start now the major concept behind atomic structure. Any doubt? Hope you don't have any doubt. Okay, we'll start now. Now we will start with the definitions and characteristics of atoms. All of you know the definition of atom, right? Atom is defined as the smallest unit of ordinary matter that forms chemical elements. And the smallest atom is hydrogen. And if you see the hydrogen atom size, this is a calculated size. It's 53 picometer. You know what is picometer? 1 picometer is 10 to the power minus 12 meters. So it's very, very tiny. And I have given one table here, which is a comparison of size of hydrogen atom with the sizes of other atoms. They are given in this figure. See the size comparison of the smallest atom, hydrogen, and one of the biggest atom, cesium. You can see the size difference. All are atoms. All these atoms are, making elements, compounds, mixtures, molecules. See their size difference. Very small atom to bigger atoms. And also you can see this part of this figure actually have taken from a periodic table. And you see this periodic table, when you are moving from left to right in a periodic table, the sizes are decreasing. But in a group, sizes are increasing. You have learned why it is decreasing, why it is increasing in your school. So if you carefully see the periodic table from left to right in a period, size is decreasing, and from top to bottom, size is increasing. Other than atom, we have to learn about ions also. For example, a neutral atom. Neutral atom means it doesn't have charge. If it loses an electron, then it will become a cation with a positively charged. Or if it releases, if it accepts or gain electrons, it will become negatively charged anions. When I talk about atomic structure, that atomic structure can be applied not only to the neutral atom, you can use it to explain the properties of cations as well as anions. For example, if I can explain the properties of oxygen atom using an atomic structure, using any of the model that we discussed earlier, I can explain the properties of an oxygen ion. I can explain the properties of an oxygen ion with the same atom model. What are the major subatomic particles in an atom? Subatomic particles means inside an atom. So there are so many subatomic particles in an atom. I'm pointing out only three. Mainly three types of subatomic particles in an atom: protons, neutrons, and electrons. Charge and mass of these subatomic particles are shown in the table. Mass is in gram. And the subatomic particles have, whether these subatomic particles have the same mass? See the mass? Are they same? They don't have the same mass, right? For example, electron is the subatomic particle which is having the least mass, which is somewhere around 9.1094 into the 10 to the power minus 28 gram. And electron is having negative charge. Neutrons have slightly higher mass than that of proton. Proton is having a mass of 1.6726 into 10 to the power minus 24 gram. And neutron is having a slightly higher value, 1.6740 into 10 to the power minus 4. Do these sizes matter? Yes. When you will enter into your first chapter in your +1, you will understand these masses have their own significance. So at that time, when you are sitting in your class, in your +1 class, you should be knowing, at least, which subatomic particle is having the highest mass, and that mass coming in which range. Like electron is very, very tiny subatomic particle compared to proton and neutron. And neutron is slightly bigger than proton. These things, when you will learn about structure of atom in your first chapter, at that time, this information will be useful for you. Charge, proton is having positive charge and neutron is neutral. Neutrons and protons are situated very close to each other and form the nucleus. So nucleus possesses majority of the mass of an atom because nucleus contains protons and neutrons which are having very high mass compared to the mass of electron. Definitely then nucleus will be heavy because it contains more number of subatomic particles with higher mass, and they are situating very close to each other. Nucleus will be having positive charge because of the presence of positively charged protons. Now, can I ask you a question? If you look at the nucleus, protons are staying very close to each other. But protons have the same charge. All protons have same positive charge. If they have same charge, you have studied, how can they stay together? Because similar charges will repel each other and there will be repulsive force. So what makes the protons bind together even though there is a repulsive force which try to make all the protons away from each other, but that's not happening. Nucleus is there. Inside the nucleus, all the protons are staying closer. Can you explain this? That you are going to study in your +1. You'll be studying which force makes all the protons bind together and to stay in a very concentrated space. At that time, you will study that. So once you join for your +1, this question will be answered. Protons and neutrons, they are in the nucleus. So we can call them as nucleons. So nucleons are the subatomic particles present in the nucleus. Now more information about atom. You have studied all these things in your school. Atomic number, all of you studied atomic number, which will be represented using the letter V, is the number of protons in the nucleus. For example, atomic number of oxygen is 8. That means oxygen atom has 8 protons in it. Another number, that is atomic mass or mass number or nucleon number, which is the total number of protons and neutrons in the nucleus. And it will be represented using the letter A. For example, carbon 12. So mass number of carbon is 12. And we know that the atomic number of carbon is 6, which indicates carbon has an atomic mass of 12, which indicates that it has 6 protons and 6 neutrons in it. And if you subtract the mass number by the atomic number, then we will get the number of neutrons in the atom. So 12 is the mass number. You subtract it by the atomic number 6, you will get the answer as 6. So 6 will be the number of neutrons in an atom. So if you know the mass number and your atomic number, then it will be easy for you to measure, to count how many neutrons are there in the atom. Now you have learned about the term isotopes. Isotopes are the atoms with the same atomic number and different mass numbers. We call them as isotopes. So isotopes, same atomic number and a different mass number. So isotopes differ in their number of neutrons. For example, I'm taking 2 isotopes of carbon, carbon 12 and carbon 14. Number of protons, here for the first atom 6, number of electrons 6, and number of neutrons 12 minus 6, 6. At the same time, for carbon 14, atomic number is 6, number of protons 6, number of electrons 6, and number of neutrons 14 minus 6, which is 8. What does it indicate? Isotopes differ in the number of their neutrons. So mass number is, if you add the number of protons and neutrons, we should get mass number. Then why sometimes the atomic mass or mass number is given like this? You see, 1.004, not an integer. If mass number is the sum of protons and neutrons, then definitely it should be an integer, right? Then why it is not an integer? Why there is a decimal term associated with the atomic mass? The reason for this is the existence of isotopes, because hydrogen in our environment or in our Earth exists in 3 different forms, with atomic number 1, with atomic and mass number 1, with atomic number 1 and mass number 2, with atomic number 1 and mass number 3. So how they are differentiated? 1H1, the normal hydrogen that we normally discuss, that hydrogen has 1 proton and 0 neutron. Deuterium, which is 1H2, that contains 1 proton and 1 neutron. 1H3, which is an isotope which contains 1 proton and 2 neutrons. So if you look at the atmosphere and if you see the presence of all these hydrogen, they are present in our nature. Majority of the hydrogen will be this hydrogen, that is 1H1, but there are traces of these 2 isotopes in our nature. So we have to consider the percentage and atomic mass of these isotopes also. So once you calculate or once you consider the percentage and atomic mass, then the atomic mass of hydrogen, that term, that value may contain some decimal. Another example I will give, like chlorine. Chlorine have an atomic mass of 35.5. Why that 0.5 comes? Because chlorine exists in 2 isotopic forms in the nature. One with an atomic mass 35, one with an atomic mass 36, and they are almost 50-50. They are almost 50-50 in the nature. So the atomic mass we will be considering, because they are staying at 50-50, I will take just an average, which will come closer to 35.5. That's the reason we write atomic mass of chlorine as 35.5. So even though, as per the definition, atomic mass is the sum of protons and neutrons, doesn't mean that always the atomic mass will be an integer. Based on the presence of isotopes in the nature, we have to consider the percentage and atomic masses of different isotopes. So the value can be a non-integer with some decimals in it. Any doubt? Any doubt?